So thank you all for coming out to see us. Today we're going to talk about AI GOAT, the vulnerable AI infrastructure. My name is Shir Sadon. I'm a security researcher for Orca Security. I've been in the security field for over 5 years. I specialize in cloud security, data analysis, and most recently, AI security.
Hi, I'm Ofir Yakobi. I'm also a security researcher at Orca Security, specializing in cloud security, web application, and also AI.
All right, so before we talk about AI GOAT, let's talk a little bit about AI. So I assume you've all heard the term before. You've probably experimented with it a little bit, if it's with ChatGPT, Gemini, and stuff like that. And I assume some of you have also developed your own models and implemented AI into your own applications. So actually, according to Gartner, we are expecting to see an annual growth of 19%, and by the year 2027, reach a market of almost $300 billion. According to our scans, we saw that out of all organizations that are using Azure, 39% have already implemented OpenAI. Out of all organizations using AWS, 29% have implemented SageMaker notebooks. And out of all users using GCP, 24% are already using Vertex AI. Another interesting thing that we saw is out of all of the organizations that are using AI services, 56% have actually adapted them into their own custom applications. And additionally, there are already over 50 AI packages available and in use, packages like TensorFlow, PyTorch, and more. And these two last data points indicate that people understand what they're doing. They're not just using the ready-to-go services provided by the vendors, and they're actually developing their own solutions and implementing the solutions provided by the vendors into their own application in a more customizable way. So that's cool, but we're not the only one that are using AI. Also, hackers are using them. We are already seeing malwares that have implemented machine learning and large language models into their code to create a more advanced malwares that are better at evading defenders' programs. And also, the more people that are using these AI packages and those new models, the more people are actually exposed to their vulnerabilities. We can actually see that over 62% of the organizations that have implemented those AI packages are already exposed to vulnerabilities native to those AI packages. Additionally, we saw that 20% of the organizations that are using OpenAI have stored their OpenAI access key in an unsecure location, possibly exposing it to unwanted entities that can use those access keys to infiltrate their account and then possibly move laterally over the entire environment. And another interesting thing that is important to note, that those organizations that are developing and are using the AI packages are using them on assets, and 10% of those organizations have actually assets that are exposed to the public using AI packages. Now, this is a risk because not only does the public have access to our models and our training sets and all of the code that we are using, but those models actually have access to the public and to the internet. And some models, depending on how we created them and how we wrote them, we don't always want them to have that access. It can be dangerous and can be teaching the models things we don't necessarily want them to learn. Thank you. So before we talk about how to secure and how to overcome those risks, we need to discuss the challenges. So the first one, just like Dave here points out, is the pace of innovation. Just like in every aspect of technology, AI is developing and moving forward by the day. We can expect to see new versions of packages, new models on a daily basis. And with those new inventions come new vulnerabilities, new ways for attackers to exploit the advancement in the technologies. And as a defender, it's nice, it's moving forward in the field, but it's also hard for us because we always need to be, on everything and make sure that we know exactly where the next vulnerability is going to come out of. The second challenge is shadow AI. So just like your regular shadow resources, services in the cloud often create resources in the back that we are not necessarily aware of. And the same thing happens with AI services. So right now we have not only shadow resources, we have shadow AI resources. So it adds up to the risk of your normal shadow resource. And the last thing is, this technology is still relatively new. We don't have enough documentation about it. We don't have enough research about it. We don't have enough protocols on how we can defend it and how we can keep our environment safe when we're using that new technology.
All right. So as Shir mentioned, we know a lot of people are starting to use AI. It's really taking off. And we have some security challenges we need to worry about. So that leads me really to talk about the OWASP top 10 machine learning risk. You have the list right here. So this is a relatively new project. It was created by the OWASP team in early 2023. The risks here are still mostly theoretical, but each one of them still poses a great threat to the models themselves and the environment reliant on them. So if you're developing your own machine learning projects, or if you want to, you need to learn and understand these risks, because it's very important to know how to protect against them, to have better security posture around your machine learning projects. I would like to take the opportunity to say thanks to Shane, Sagal, and the rest of the OWASP team for creating this project and collaborating with us on AI Goat. And speaking of AI Goat, basically that's why we're here. Let's talk about what is AI Goat. It's our open source project. It creates a deliberately vulnerable AI infrastructure based on the OWASP top 10 machine learning risk we just saw. Basically, the application includes intentional multiple misconfigurations, vulnerabilities, and security issues. It is used for testing purposes and learning, basically a way to hack it yourself, hands-on kind of experience, to learn machine learning vulnerabilities. So we have here the QR code to our GitHub repository. You can scan it and check it out yourselves. Basically, anyone can deploy it. When you deploy, you get a user interface, basically a cute toy web store, as you can see in the image. It has like the vulnerabilities inside of it, and that's what you're going to want to hack. The infrastructure behind the scenes is AWS. The models are built on Amazon SageMaker. That's pretty much that. And we also currently we have 3 challenges to complete, each one of them with different difficulty level. Yeah.
Okay. So in order to solve our challenges, we need to understand a little bit further about the risks. So the first risk we are going to talk about is AI supply chain attack. Just like your regular supply chain attack, an AI supply chain attack is when the attacker attacks the chain of supply. I know I'm using the same words to explain itself. So basically what's happening here is that instead of attacking the model itself, the attacker is looking for vulnerabilities in something the model is reliant on. For example, a package the model is importing, or misconfigurations in the infrastructure the model is hosted on. We can see examples of it in the wild. Those attacks are already happening, Shelltorch here, for example. The second attack is data poisoning attack. This attack happens when the attacker gets their hands on the training data, the model's training data, and changes it. Sometimes a drastic change, sometimes a very minor change. The point is that those changes make the model behave differently in a way that the developer did not expect it or intended. We can see here, sorry, I'm pointing here, you don't see it. You can see here in the visual representation of it, you have the normal data set opposing to the poisoned data set, and it directly affects the model and the way it behaves. The third risk we will be discussing today is output integrity attack. So in this type of attack, instead of going after the model itself or the data, I'm so sorry. Instead of going after the model itself or its data, the attacker just changes the output. The model works as it should work, everything is fine. The attacker somehow manages to infiltrate the way the model works. Maybe it's a man-in-the-middle type of attack, maybe a web attack, something like that. But the point is just the only thing that is changing is the output. There was actually an example of something like that that happened in 2023 when an attacker targeted a health diagnosis system and caused it to give out wrong diagnosis. All right, so another thing we need to understand before we move on to attacking the website is its architecture. So AI Goat, as Ofir already mentioned, is a website. It's hosted on a bucket, not this one, a different one. The website is basically a toy store. And it has several features that are using AI models, machine learning models inside of them in order to work normally. And I'll tell you a secret, there are some vulnerabilities in those models or in their infrastructure or the way they are implemented in the website. So the way these models are built is the little drawing that you see here. We have the SageMaker notebook that is actually in charge on running all of the code that we need, the training jobs, the code itself, creating and teaching, and the entire learning process happens inside the notebook. Everything, all of the data that is needed for the model to work correctly is saved on the bucket. It's usually a default bucket created by SageMaker, but not necessarily. You can configure it however you'd like. So after we finish the entire learning process, everything is fine. What we get is a SageMaker endpoint, and that endpoint is actually in charge on generating our predictions. In order to make the endpoint generate the predictions, we are using a Lambda function, and that Lambda function connects to our web server through an API gateway. So to summarize everything up, we have a web server that communicates with our Lambda function via an API gateway, and that Lambda function is in charge on invoking the endpoint and generating predictions according to what we are sending it. Okay.
Okay. So I just want to give you a quick walkthrough on how to set up your own AI goat. So basically, all you would need is an AWS account with administrative privileges to set it up. Setting it up is pretty straightforward. It's pretty much easy, fully automated, and we have two ways of doing it. The first option is basically doing it locally. You clone a repository, you configure your AWS profile, and then you run Terraform apply. And the other option is doing it using GitHub Actions. Basically, you will fork the repository, and then in your own one, you will need to configure in the GitHub Actions settings, you need to configure your AWS credentials, and then simply run the GitHub Actions, the Terraform apply GitHub action. And after you do that, you will have, in both cases, the Terraform output. As you can see in the right screenshot in the red box, you will get basically the bucket URL, which is our website where we're going to start off with everything. And also a backend IP address. This is where we have kept some clues and hints. If anyone is having trouble, they can access it. Thank you. So now we're going to dive into our demos. So the first one, we're going to implement the AI supply chain attack. 1 second. Basically, we have here a model in our website, image similarity model, where we have a product search functionality. We upload an image. The model behind the scenes tries to find the most similar product in our website, and then it gives us back the answer. And in our attack scenario here, we're going to try to find some sensitive data somewhere here. So as I said, we have the product search functionality. We're going to just try to check it out ourselves and see how it works. So yeah, we're going to access it. This is the website. We're going to upload some image, some fox doll we found on the internet, and then we're going to see just how the model works. So this is just the regular reply. We get the fox doll and some other things. So okay, let's try maybe see behind the scenes, see the request, and see how it works, if we can find something interesting. So once again, we will upload the image, and then see the request, and see if we can find anything interesting. Okay, so this is the request we have. We can see the analyzed photo. This is actually the request we sent with the images, the payload. And then we can also see something interesting. We have some API requests getting an error, an API pre-processing, image pre-processing request. Since we know our model is taking an image, we can assume it has some pre-processing before it's being sent to the model, so it can do the predictions. So this might be very interesting to us because we know the website is using this and then sending it to the modeling somehow. If we take a closer look at the error, we can see we have some kind of GitHub repository it references us to. So sounds very interesting. Maybe we can try to see if this GitHub repository is accessible, if it's public. We're going to try to investigate the code maybe, see if we can find something interesting. So yeah, we can see it's public. We're going to access it maybe and see what's inside of it, read the code a little bit. And if we take a closer look, we can see it's in fact what we expected. There's some kind of process image function. It does it using some pillow library, and then it returns the image data. But if we take a closer look, we can see the function actually searches for metadata inside the image. And if it actually finds it, it runs it as shellcode. So this is obviously very interesting. This seems to be like a vulnerability inside this function. You can see it runs the shellcode and returns the output. Obviously, we're going to try to exploit that. We're going to try maybe create our own image and add the metadata content inside of it, maybe edit with some bash command, and then upload back to the website. So we already prepared this Python script. We can see we're trying to do here ls and just the EC2 user directory, and see if we can find anything, see if it works. So we're just going to save this image and download it, and of course, we're going to upload it to our website. And let's see what we can find. So as you can see, I uploaded the photo, running the search. We can see the request failed this time, but we actually got the metadata output as we saw in the code, and we can see we have a file called sensitive data. So this is very interesting. So it seems like what we wanted to find. Obviously, we're going to try to read it. We're going to create another image with the same, the command to read it, and we're going to upload another image, the new one we created, in a minute, and then we're going to try to see if it worked and what we can find. Yeah, so as I said, uploading the new image. In a second, I will show you what we're going to find. OK, so we can see we got a response, user recommendation data set, SageMaker recommendations bucket. We seem to have found some bucket name related to a recommendations data set. Seems to be very interesting. We're going to keep that in mind for our next challenge. OK. No. All right. So just a quick recap of what we just saw. We had the image seriality model behind the scenes in our website, where we simply uploaded an image, and it gave us the most similar product in our website. And the risk we saw, the model was using a vulnerable package, actually a package we created, but it was vulnerable and led to an SSRF attack on the backend server. The other risk was mishandling of the user input. We could upload the image with the metadata content being malicious, anything we wanted to do, and it worked as expected. So basically, how you're going to defend from it, the first thing, you need to have good vulnerability monitoring. This is something very important throughout your project, in everything. In our case, specifically in supply chain, you can have multiple dependencies in your project. Some things you don't even remember. So having good vulnerability monitoring will help you keep track of everything, specifically for any new CVEs coming out or something that might be very problematic. The other thing is user input validation and limitations. This is also very important throughout your project. You need to make sure to sanitize the user input, have some limitations on it. Don't allow everything. Don't allow anything with that input, whether it's image, text, whatever. And another important thing is the verified package signatures. You need to make sure your packages are what you expect it to be. You need to make sure you have the right authenticity for your packages, and make sure that it correlates with the one the vendor supplies. OK, so now we're going to dive into our next scenario, which is the data poisoning attack. OK, so in our case, in this case, we also want to keep in mind we have the bucket name from the last challenge. But this time, we want to try. Yeah, seems good. Yeah. I hope you can see it. So in this case, we have some custom user recommendations in our website. Basically, every user gets a product recommendations based on their browsing history and activity in the website. And our goal here is basically to modify it to something that we want. We have a product in the website which is also hidden, some ORCADOL. We want to try to make it highest in the recommendations. So we have two goals here, basically to find the ORCADOL product and then make it highest in the recommendations, because it's currently not in them. And we also want to keep that bucket in mind, because we are going to try to see if it's related, because it's called recommendations bucket. So as I said, it's a user recommendation, so the first thing we're going to log in with our user. You have it in the GitHub repository documentation. So after you're logged in, we can see we have these recommendations already set for us. I hope you can see it in the bottom left. It was the product IDs. It was 3, 4, 13, and 19. These are the products that were currently recommended for us. And now we're going to try to see, the first thing we're going to see is what is the Orcadol product ID is, because that's the one we want to change. So you can simply do as I'm going to do now. See it in the website, look around, you can see this is product ID number 1, this was number 3, and number 4, and so on. So we can see number 2 is missing. You can also do simple crawling for the website. You will see number 2 is missing. We can assume that's the product for the Orcadol. And now, if we come back to the bucket name, since we know as in the architecture, as Shir explained, we had a bucket name. We had a bucket that stored the model data and the data set for our infrastructure. So that might be very interesting for us to try to see what we can do with it. So we're going to first thing, we're going to try to see if we have access to this bucket, just to read what's inside of it. We can even do it anonymously, see if it works. And we can see it did. It has some very interesting things inside of it. It has the model data. We can also see it has some interesting file called product rating CSV. So this is obviously very interesting. We can download the whole contents, try to investigate it. But we're going to focus on the product rating CSV for now, because we know we're trying to affect the recommendations that are based on product ratings. So we can assume it might be something interesting for us. So as I said, we're going to maybe try to download it. So I'm just downloading it to my local computer and try to take a look, maybe see what's inside of it, and see what I can do. Maybe I can try to modify it in some way, upload it back to the bucket, and really affect the way the model is working and the data set for the model. So we're going to investigate the file, hoping you can see it. It might be a little small right here. So we have the user ID, product ID, and ratings in the CSV file. So if you take a closer look, this might be the data set for our model, as we said. The first thing we're going to try to see, we have the already recommended products. We have number 3, 4, and so on. We're going to try to see how their ratings look like, because we want to imitate that, obviously. So I'm just going to filter on number 3. And then we can see the results seems pretty high. We have 4, 5. Also, we're going to do it for number 4. It will be the same. It's pretty high, 4 and 5. If we have a closer look, it's also a hint in here. You have the product ID number 2 in the ratings, meaning there's product ID number 2. Just a hint that our Orcadol is really number 2. And what we're going to try to do is maybe override. Maybe I can try to modify the product ID number 3 into make it number 2, so that mine will be higher. So number 2 would be recommended. So as I said, we just override everything that was number 3, and I'm going to give it all the highest rating I can. I'm going to give it all number 5. Seems to be enough change that might be OK. I'm going to save this file. And as I said earlier, I want to try to upload it back to the bucket, because it might trigger some retraining mechanism for the model eventually. We know that it happens sometimes on different times or even immediately. So I will just try to upload it back, as I'm doing here. You can see I'm uploading product ratings. And I'm also going to give it the flag of the bucket owner full control, just to make sure the file I'm uploading won't lose any permission it has in the AWS account. OK, so I'm uploading. I can give you a little spoiler. It does have some retraining mechanism behind the scenes. It usually takes like a couple of minutes, like 5 minutes to retrain, simply because it actually does the retraining of the whole model and setting up a new endpoint. So I created like a mini API script, API call here. You can see the SageMaker endpoint status. It's currently updating. So this is very good. It means actually we did something, because before it was running. If we come back in a couple of minutes, like 5 minutes, refresh the website, we can see if the result has changed. And we can see it did. We have the Orcadol, meaning we succeeded. If we take a look at the API call, this time the endpoint will be running. OK. Sorry. All right. So let's just do a quick recap. Basically, what we just had, We had the user recommendations model behind the scenes. We have the recommendations of the products. It was stored, the data set for the model was stored in a public bucket. And we were able to access it, which is actually the first risk. We were able to access it, also read and write to it, and that led us to eventually change the recommendations. And the other risk is the data integrity. We didn't have a proper data integrity for the bucket. The retraining mechanism happened on data that wasn't meant to be, something that we changed. So yeah, these are the risks. And as far as mitigations, how are you going to protect yourself from it? So as I said earlier, we have the data set integrity validations. You always need to make sure your data, specifically if it's important one, you need to make sure you have checks before doing anything important with it, whether it's checksums, anomaly detection, or even something as manual checks. You need to make sure that what your data is meant to be is what it is, and not something that's been tampered with. And another thing is access control. Obviously, we had the public bucket, which is something very bad. Don't allow public assets when you don't need to. And if you have to do that, you need to have proper access control set in place, have the proper authenticity for those assets, and make sure only the authorized personnel can access what they're intended to.
All right, thank you, Ofir. Now let's move on to the third and final scenario for today. So this one is output integrity attack. Our goal, I'm so sorry, you can't see. I hope it will focus in a few seconds. Okay, so we are picking off where we left off with Ofir, the Orca dolls page, the comment section. And our goal today is to comment the word pond, but I'll tell you, you will not succeed because we have a comment filtering model behind the scenes that is preventing us from commenting about bad words, and it thinks that pond is a bad word. Okay. Let's try to see how we can bypass it. And of course, the first thing we'll do is look behind the curtains. So just a second. OK, so let's comment again. Let's see what's going on, what's happening. We can see we got an error. The payload that is being sent includes these values, author, content, is offensive, and probability. And the response we receive, we get an error, comment is not allowed, and is offensive is 0, probability 0.8. Okay, now let's see what happens when we comment a word that is allowed, like great, because we only allow good, never mind, forget the word. Okay, so we can see the payload looks the same, just the content is changed, and the response, we can see that we have ID, that we didn't have it in the first attempt, and that is offensive is 1, as opposed to 0 when we try to comment the word pond. Okay, so what I would do is try to alter the payload a little bit further. And in order to do this, we just opened bWAPP. So we'll use bWAPP to have a more flexible options. And we'll start off just by checking out how it works. Let's see, comment gray. Let's make sure that we're receiving the same output we're expecting to receive. And we did. We get ID. We get is offensive 1, meaning it's not offensive. Let's see what happens if we comment the word pond, just to make sure everything is working as it should. Yes, we're still getting the error, is offensive is 0. Okay, so now we need to bypass it. The first thing I would try is to change the author's name, because now we have new user. What happens if we write admin? Maybe it'll give it. No, not working still. We're still getting the error. We're still getting is offensive 1 and probability the same. Okay, so we try to change the content. We try to change the author. Now let's look at is offensive and probability fields. What we can assume from the responses we got so far is that is offensive is what the model is, it's the model's decision. It's what it says if it's offensive or not. And the probability is how sure it is of its response. The weird thing is that we're sending it in the payload, because this is the answer we're receiving. We're not supposed to be sending the fields in the payload. So let's see what happens if we try to putting values on our own. So right now it's just, okay. So we'll try sending is offensive false. Let's see if it's working. It's not, probably because it's expecting a numerical value. We've been receiving numerical values. So let's try to put on 1, because that was what we received when we commented great, and it's still not working. Maybe we need to change the probability too. I keep pointing here, but you can't see it. I'm sorry. Okay, so if we send is offensive 1 and probability 1, we can see that it's actually working. We got ID 11. Let's see that we can actually see it on the screen. And we can see that the word pond was being commented. Okay, so let's do a quick recap. I'm sorry, this is annoying. Okay, good. Okay, so let's do a quick recap of what we actually did here. We had a goal of commenting the word pond. We were restricted by the comment filtering model, but we found out that if we are sending the values that we want to receive with the payload itself, the website ignores the model's predictions and is actually using the values that we sent it. We can assume it is probably happening due to caching reasons. The website doesn't want to keep querying the model on the same word, so it uses values it already has. The risks that we saw here is improper input validation. As a user, I'm not supposed to be able to give the website my own predictions or my own values of what it's supposed to happen. The only value I should be able to send is the comment itself. And the second one is improper output validation. From the point where we receive the prediction from the model up to the point where we displayed it to the user, the decision took a few steps. And in no step, the website made sure that the comment and the decision of the model stayed the same. So there was an improper output validation. The possible mitigations are, first, integrity checks. Always make sure that what you are claiming to be the model's output is really the model's output and that it wasn't changed or altered somewhere in the process, maybe by a bug or a mistake or sometime an attacker like us. And the second mitigation is input validation. Always make sure the model you're using is only receiving what you intended it to receive, nothing more, nothing less, in order to prevent this attack and so many other attacks. Okay, so we have discussed a few risks. We've discussed a few mitigations. We saw some real-life examples of it. Now let's discuss how we can generally protect our machine learning environment we are working on. So we have a few solutions we've already discussed. For example, access control, principle of least privileges. Do not give any assets in your machine learning environment any permissions they shouldn't be receiving, if it's the model itself or if it is people that can actually access the model. We want to keep it as sanitized as possible. The second one is input and output validation. We just discussed it. Only receive what you want to receive and make sure that you are giving out what you intended to give out and what you are claiming to be giving out. The third is vulnerability management. Ofir talked about it. In order to keep your environment as safe as possible, your cloud environment in general, and specifically your machine learning environment, you need to make sure you know exactly what vulnerabilities you're exposed to, what their severities are, in order for you to make better decisions and to keep your environment as safe as you can. The fourth one is continuous monitoring. I think the key point in order to detect attacks fast and efficiently is to know exactly what's going on in your environment, specifically in the machine learning models. You want to know exactly who accesses the model, who accesses the training data, the data sets in general. You want to know what the model is receiving, what the model is putting out. And you also want to know how much people are querying it, what the quota is, what resources the model is using in order to provide their answers. And that way you can detect anomalies better, faster, and possibly prevent the next attack, or detect it just faster than you would have without any monitoring. The fifth thing is no sensitive information in the training data. I hope it is obvious to you. The models are still not reliable enough, they're not secure enough, a lot because of the challenges we discussed earlier. You do not want to give or to train your models on sensitive information that you do not want people to be aware of, or data that might leak into malicious factors. And the final principle, in my opinion, the most important one, is education. As we all know, the number one risk in the cybersecurity world is the human factor. In order to overcome it, the main solution is education. If you educate your developers to develop the machine learning environment in a secure way that follows best practices, and follows good vulnerability management protocols, you would be able to reduce the risk of your machine learning environment being targeted or attacked by a lot. And I, for one, think it's the most efficient way to keep your environment as safe as you want. Okay.
So let's talk a bit about what's next for us and for this project. So the first thing we aim and our goal is to cover all 10 OWASP machine learning risks, as we said earlier. And as we speak, we're currently working on some new challenges, hoping to release them in the next few weeks. Another really important thing for us is to create a fully local version of AI Goat. Our current one, as we said earlier, is depending on having an AWS account. We do want to make it fully local without any dependencies on any cloud vendors, because we want to make it available for anyone who wants to try it out themselves. We know not everyone has an AWS account. So yeah, we want to create a fully local version, also work in progress. Another thing really important for us, one of the motivations behind building this, we want to increase the overall awareness of the machine learning vulnerabilities out there. Our goal here was really to make the OWASP risks come into real life. As we said, they're still mostly theoretical, and we do wanted to show them in something that might be a real case, a real website, someone that how people actually use it. So again, you have here the QR code for our repository. You can scan it if you missed it before. That leads me to the next point. We welcome you guys, everyone, to try it out yourselves. We welcome any input. We appreciate the power of the community. So since this is an open source, we would like some people to give their input. So again, you can contact us on the GitHub repository. You have here our LinkedIn account, sorry. And you can come up to us here if you want. And that's it. Thanks everyone for coming.
Thank you, guys.
Thank you very much.